Welcome back everyone to the second video of the series, that is smart contracts in 30 days. In this video we'll be learning about how to write calculator in Solidity. So let's get started. So open your Remix IDE and create a smart contract. So as we have done in the previous contract, let's have the license. We have to have the license and the compiler version, and the name of the contract is calculator. So in this program we'll be writing mathematical operations: addition, subtraction, multiplication and division. Let's have a variable result. So result is a integer in Solidity. So integer can be unsigned or signed. The range of the unsigned integer is from 0 to 2 power 256 minus 1. So unsigned integer can also be written as 256. That means it has 256 bits of data, so it can also be written like this. Let's write a function which adds two numbers. So in Solidity, to write a function we need to write function keyword, function name, and the parameters will be a and b, and so we have a function here. So we have to mention what is the data type of a and b. A will be uint unsigned int, and what this function will do is it adds a and b and assigns it to the result. Plus b. So result is a state variable. So everything we do on result actually consumes gas, and the data is stored on blockchain. So this function returns nothing. This is a and we want to access it from outside, so we want the visibility to be public. And let's write one more function which gets the result. So let's write a function get result which has no params, and it returns result. So in Solidity we need to mention what is the type it returns. So this function returns uint, and so we want the visibility of this function to be public, and this function does not alter any state. This is only reading from the state. In that case we have to mention it as view, which consumes lesser gas. Do not worry about what is the infinity gas and gas 542. We will learn about it later in the other videos. So let's compile this. Let's deploy this, and we have the contract deployed, and we have a method add, and we have one more method get result. Right now if I click on get result, it got executed and we have 0, and if I add 1, 3 and the method executed and we have the result 4. Fantastic. Let's do one more function, subtraction. So subtraction, same as addition, the only difference is we have a minus b instead of a plus b, and let's recompile and let's deploy it, and we have our second smart contract. So right now the result is 0. Let's subtract 5. Let's subtract 5 minus 4 will be 1. Wonderful. What happens if I subtract 6 from 9? It should be minus 3. But if I get the result, it says there's an error. The transaction has been reverted to the initial state. The reason for this is the result is unsigned integer. There are no negative numbers in unsigned integer because it starts from 0 to this number. In order to make it take negative values, we need to put it as integer, and it takes values from negative this number to positive this number. This is the range of integer. So we have an error which says the result is integer, and we are summing up two unsigned integers and trying to put it in integer, so which is not possible in Solidity. So in order to fix this, we need to make a and b also as integers. And the result is joint. Let's compile and deploy. So let's try 4 minus 5, and it's minus 1. Cool. And next one is multiplication. So multiplication is a challenge for you guys. Try it out yourself and let me know how did it go. And let's do the division. We want B to divide A and give us what the result is. And let's try it. Compile and deploy, and we have subtraction division. We want 6 to be divided with 3 and get result 2. We want 5 to be divided by 2. We still have 2 because the integer will only take whole numbers. It will be 2 point something, but the integer will only take the whole numbers. And if we divide 2, 0, we have an error. So in order to prevent this, we never want b to be 0. So the requirement here is b should be always not equal to 0. So in Solidity we can write this condition using a require statement. So the require statement takes a condition. The condition is b not equal to 0. So if b equal to 0, the error should say b should not be 0. It says b should not be 0, and if it is 1, we get the result 3. That's all for now. Let's see you in the next video.